Today we're going to be looking at the 2013 March Silver question, the cow run. So in this question, Farmer John forgot to repair a hole in his fence, so his N cows have basically left the farm and are going to be causing $1 worth of damage for every minute they're outside the fence. So what's going to happen is Farmer John is going to move at 1 unit of distance per minute, and he's going to stop a cow every time he reaches the location that the cow is in. So what we want to do is we want to find the minimum total amount of damage cost that could possibly be inflicted. So let's go look at the algorithm for this question. So the main algorithm we're going to be using for this question is going to be DP, or dynamic programming. And so we're going to make one main observation, and though this observation may seem simple, it's going to be really important. So what this observation is if I start here, and I want to travel here and stop this cow. If I have 2 cows here that I want to stop, what I can basically do is I can create a range of the cows I've stopped. Since if I've stopped this cow and I've stopped this cow, it's always going to be optimal to stop all of the cows in the middle. So what we're going to do is we're going to create a 3D DP. So I is going to be the start, J is going to be the end, and then we're going to have a third value which is going to be 0 or 1, depending on whether or not we're currently on the beginning or the end. So the next main thing we're going to do is we're going to have 2 for loops. So we're going to loop through, and then we're going to have the first for loop be I, or the start, and then the second for loop be J, or the end. And we're going to loop in order so that we have the smallest ranges and then the largest ranges. So we're going to go from smaller to larger ranges. We're going to have the transition where we're going to have, assuming that this is 0, the max of dp I plus 1j, 0, plus the distance between cows I and cows I plus 1. So let's assume this is our current range. We're going to have dp I plus 1j, and then we're going to add the distance between cows I and cows I plus 1. So that's going to be this distance here. Or we're going to add the distance between cows j and cows I. So that's going to be dp I plus 1j, 1. And then since this is 1, we're going to assume we're here, and then we're going to add the distance between this and this. So there's still going to be scenarios where, let's say this value is like infinity, and it would always be more optimal to start here, and instead of going to the next value, because this here is too expensive, we're going to go and we're going to stop this cow here. So obviously infinity is a bit of an exaggeration, but you get my point. So we're going to do that for dpij 0. And then for dpij 1, we're going to do the exact same thing but reversed, and I'll show you more of that in the code. But the basic idea here is we're going to keep our dp out of range, and we're going to build on smaller ranges to larger ranges. And when we build them on, we're going to add the distance between. So when I say distance, I'll show you more of this in my code, but it's not actually going to be the distance, it's going to be the cost. So let's go look at the code for this question. So I've set up the program a bit here. We have our DP, and then we have our input and output. And then I'm going to read in our main vector, which is going to be cows. So the next thing I'm going to do is I'm basically going to set up our DP. So what we're going to do is we're going to have dpii, which basically means the range between I and I, or just the thing itself, is going to be the distance function and then our parameters. And then dpii1 is going to be the same thing. So our distance function is going to be a little bit more special. So for every second that passes, we're going to note that we're going to have n cows, or n minus the number of total cows already silenced, amount of money. So what we're actually going to do is we're going to have 2 values here, a and b. So a and b are basically going to be the amount of time it takes. So since Farmer John starts on the very left, when we're setting it up, it's just going to be the location of cow's I. So we're just going to assume he's going to run all the way out to cow's I. So this is going to be the distance that Farmer John travels. And then C is going to be the number of cows already silenced. So n minus C is going to be the number of cows that have not been silenced times the distance Farmer John is taking So that's going to be the amount of money that this takes. So for DPII 0 and 1, we're going to have the same values. And then the next thing we're going to do is we're going to set up I and J. So again, I and J are going to be our ranges. So I is going to be the current starting location, and J is going to be the current ending location. So they're going to be the two sides. And we're going to start with a size of just 1, and then gradually move greater and greater. So we're going to start by setting up our values as the maximum value. And then the value of silenced is just going to be J minus I. We're going to assume J is not inclusive. And then we're going to have two basic things. We're going to check if I is less than n, then we're going to try cows I plus 1, and then we're going to try two different things. We're going to try dp I plus 1 j 0 plus the distance between cows I and cows I plus 1. So this is assuming we're on the left side of our range right now. Or we're going to have dp I plus 1 j1 plus the distance between cows I and cows j. So what we're basically going to do is we're going to do exactly what I described in the algorithm earlier. So the next thing we're going to do is we're going to check if j is not equal to 0. And if it's not equal to 0, we're going to try the two values here. We're going to have dp I j minus 1, 1, plus the distance between cows j and j minus 1. Or we're going to have 0 plus the distance between cows j and cows I. So that's basically our DP. So the hardest part would be looking at the algorithm and figuring out the state. So at the very end, we're just going to output the minimum between the entire range of everything, and then ending at either the last element or the first element. And that's the end of our program.